Hello everyone, welcome to Coding with Avinash. Welcome to today's video. Today we'll be discussing about a comprehensive roadmap for becoming a software engineer in 2024. Whether you are a college student, whether you are a fresher who is looking for a job, or an experienced candidate who is looking to switch over a new role by knowing what are the latest technologies in the market and what would be the right roadmap or right path to learn the technologies such that you will be landing into your dream company on your dream job. So let's go through the roadmap. So let me walk you through the roadmap. I have divided this roadmap into 7 clusters where we will be discussing on programming languages and what are the better programming languages to have a grip on, and then we will be discussing about databases, and then what are the different tools and things which we need to know in web development, and data structures and algorithms, and what are the different life cycles we have in our software development, and what are the methodologies which the current industry is using. And at the final step we will be seeing like which are all websites are good for practicing programs and practicing coding. So first let's dive into programming languages. Here I have divided it into backend and frontend. As you're already aware of, you should have already been having knowledge on like what is a frontend. So on the frontend part is the one which the client or the customer will be facing. So this will take the responses and preview the responses on the screen, and backend is the one which dives into the business logic, which plays with the repository, which stores updates and retrieves from the repositories. So going to the backend, I have currently added Java and Python as 2 important technologies to learn in backend. So any one of the technology you can concentrate on, and if you are like interested in like machine learning, as as today it's the popular term which is being trending, and if you are interested toward data analysis side, or machine learning side, or if you want to become a data scientist, Python would be one of the best language to learn. It's a bit simple when compared to Java, but also very powerful. So Java is also one of the evergreen technology which is from the past and currently trending in software industry. So coming to Java, let's deep dive into Java. So I have divided Java into multiple clusters again. So first we will be having core Java, where you will be learning all the core Java concepts like about for loops, if conditions, variables, all these things. And then we would be concentrating on the collection frameworks. When I say collections, like we will have array list, hash map, tree, tables, hash tables and all. So this we will be mostly using collections in Java, like whether to retrieve the elements from the database or to batch insert into the database. So most part of your project coding would be on collection frameworks. And then we will be going through OOPS concepts. These are the basic concepts. These are the basic concepts of Java, you can say. And then we'll be need to gain knowledge on multi-threading. In multi-threading, like what are the new features that are introduced in Java 8 version of multi-threading, like completable future and all. So this multi-threading is nothing but like if you want your application to run in multi-threaded environment, how to code an application using multi-threading, and what are the different methodologies you need to adapt to, and like what is thread pool size, how will you run asynchronously, all these things you will be learning in multi-threading. And then we will be going to the JDBC connectivity. This is like how to connect to your database, how to connect to your repositories. That all you will be learning in JDBC connectivity. And this is one of the important framework in Java, which is Spring framework. And the Spring framework I have divided it again into 5 clusters. So we will be dealing with Spring Boot. We will be dealing with Spring Boot, and then we will be dealing with Spring Data JPA. So this Spring Data JPA, currently we are doing a series on. This JPA is like how to retrieve from database or how to insert into database using JPA. And then Spring Security. So for your application, security is the first main step. So you need to make your application secure. So we'll also be going through the Spring Security, and then Spring Reactive Programming. So if you want in non-blocking and asynchronous way of programming kind of framework, you will be going with Spring Reactive Programming, where you will be having Monos, Flux, and event driven architecture in your Spring Reactive Programming. And Spring AOP, this is aspect oriented programming, like where you will be covering on how to reduce the boilerplate code instead of writing all the boilerplate code, how to use aspect oriented things of Spring. So in Spring you can concentrate on these things, and you can add or remove a few based on your comfort. So post Spring framework I have written for ORM, which is object relational model. So whenever you want to connect with database, you will be using these ORM networks by which you will be converting your POJOs into object POJO objects into mapping to map with the repositories. And coming to ORMs, we have a couple of ORMs like Hibernate, which is most frequently used in most of the applications, and we have MyBatis, which is an XML based ORM framework. This is all about Java. So now we will be going through Python. Python is a powerful ecosystem, like as I introduced before, like Python, if you want to go towards machine learning, or if you want to go towards data analytics side, Python will be one of the program which is one of the language which is used very rigorously in these fields. So it offers a powerful ecosystem including Python standard library, web frameworks. I can say like web frameworks like Django, Flask, and asynchronous programming, with Asyncio. Dive deeper into testing frameworks like unit test and PyTest, we can say, for testing framework. And then we'll explore data analysis and visualization libraries like we'll have different libraries like pandas and matplotlib, Seaborn, and NumPy. And then additionally Python is used in machine learning and AI, as I said before, like with libraries like TensorFlow, PyTorch, Sticklearn. All these things will be covering as part of Python. So this is something where you can touch upon Python. So we have seen on backend. Now let's go to the front end. So I have divided front end into 3 clusters again, where we'll be having JavaScript, HTML5, and CSS3. And JavaScript internally I have divided into 4, where you can learn either of this, like you can concentrate on ES6 plus React.js, Vue.js, and Angular. I personally prefer React.js or Angular. So in React.js we can learn on Redux and React Router, whereas in Vue.js we can learn on Vuex, and in Angular we can learn on Angular CLI. So there is also HTML. I think most of you guys are aware like what HTML is. Like that's the basic scripting markup language which we can say that's used to design our pages and front end. So again we parallel to HTML5 we can also learn CSS3, and in CSS3 like we can concentrate on things like CSS preprocessors like Sass and Less, and CSS frameworks like Bootstrap, Tailwind, CSS, and all. So these are the things which we have covered as part of front end. So now let's go to the other part. So we have covered programming languages. Now let's dive into databases. So I guess every one of you know like what a database is, like which is used to store the data of your application, or the store the data, we can say DBMS, which is database management systems. And in database I have divided it into 3 clusters, which is SQL, NoSQL, and ORM. In SQL you can learn either of the thing, like you can know Oracle, MySQL, or PostgreSQL, where all these 3 are SQL databases. And coming to the NoSQL, like we need to understand like why what is NoSQL firstly, and why NoSQL came into the picture, and instead of SQL in which all scenarios we need to go into NoSQL, like if you want to deal with a large number of data set, like a huge number of data set, and if you relational mapping is not your cup of tea, then you can go for NoSQL databases. And in NoSQL databases, these are few of the famous NoSQL databases like MongoDB, which is of document style, and Cassandra, and Couchbase. Couchbase is also like a JSON documents database, or Firebase. So these are the famous NoSQL databases. And later we can go through the ORM. As I said previously, it's like object relational mapping. So Hibernate is one of the famous ORM. We have SQL Alchemy for Python in case of Python, and Hibernate and MyBatis in case of Java. So if you want to talk to your database, you will be using a ORM network. In that, Hibernate and MySQL will be also be useful for Java, and SQL Alchemy for Python. So this is something about database. Now let's go to web development. So in this web development, I have divided this mainly keeping microservices and DevOps in picture. So for web development, we need to know like we need to like what is RESTful API, like what is the difference between a regular API and a RESTful API, like what is the difference between a SOAP API and a RESTful API. And in the RESTful API, we need to know like what are the different methods, like how you transfer the data, on what are the protocols like get, put, post, delete, and then API authentication like JWT tokens, JWT authorizations, you will all be seeing in the RESTful APIs. And then microservice, which is very famous. So we need to concentrate on 4 different clusters of microservice, which is of load balancing, event driven architecture, service discovery, and API gateway. So APG will be like one of the API gateway and event driven architecture. So if you are dealing with a transaction and there are a couple of microservices, how would you track transaction from throughout all the services, that you will be dealing with microservices. And then we'll see web security. In web security, you need to have knowledge on cross-site scripting, cross-site request forgery, and OWASP in case of web security. And DevOps, it would be better if you have knowledge on DevOps tools as well as your technical stuff like programming knowledge. And if you don't want to go into the programming technologies, and if you want to go only to DevOps, that is also possible. So in case of DevOps, you need to know like what are the different version control system, like example Git, what is GitLab, what is GitHub, or what is Tortoise SVN. And then you need to know on CI/CD, which is continuous integration and deployment. As part of CI/CD, you will be having something like Jenkins, GitHub Actions, which is also very famous CI/CD, and Travis CI. And then you need to know on containerization, like Docker. So if you want to deploy your applications onto the server, like you will be writing a Docker file, and then you will be containerizing that Docker file. You will be using Docker, Kubernetes, and all that you can cover in as part of containerization. And then it would be better to have hands on any of the cloud platform. It's need not like you need to know every cloud platform. We have Google Cloud Platform, which is GCP, we have Microsoft Azure, and we have AWS. It's better to have hands on in any one of the clouding platform at least. And in the clouding, like you need to have idea on compute services like EC2 server, Azure VMS, and compute engine, and storage services like AWS S3, Azure Blob Storage, and all. And database services like RDS, Azure SQL database, and serverless computing like AWS Lambda, Azure Functions, and all. And this is something about DevOps. So we have seen DevOps and web development. So now let's go to DSA, which is which I can say one of the basic fundamental, or one of the very strong area where you need to be fundamentally very strong, which is nothing but the data structures and algorithms. So I have divided it into a couple of categories where we need to concentrate on data structures like arrays, linked lists, stacks and queues, trees and graphs, meaning like which data structure we need to use in which kind of scenario, like when you need to go to arrays or when you need to go to linked lists, when in case of retrieving or traversing, it would be better to use a linked list than arrays. And when to go with stacks and queues, or when to go with trees and graphs, we need to have an idea on those things. And post that sorting algorithms, we have a couple of sorts, like for example, if there are random numbers, how to sort it in structured way. We have different sorting algorithms like bubble sort, merge sort, and quick sort. You should be having idea on these sorting algorithms. And then searching algorithms, we have linear search and binary search, which we need to have knowledge on. And then I can say dynamic programming like memorization, which we need to have idea on. So this is something about data structures and algorithms. And post that we will be going to software development life cycles, and we will see like what are the different phases in your development life cycle, like what is the first phase, like how you will be analyzing the requirements, how you will be getting the requirements, how you will be documenting them. You will be having different tools here like Confluence, Jira's, and all. And it's also very important to know design patterns, like you have abstract factory design patterns, build up design patterns, singleton design patterns, and event driven architecture, saga design patterns. So all these design patterns, at least few you should be having idea on. and then implementation, how would be implementing your user stories, how would you be implementing your requirements, how you picturize them, and how would you bring them live. All these things you will be seeing as part of implementation. And coming to the testing, as part of unit testing, the developer will be doing Mockito testing using power tools like Power Mockito, and all. You should also be having idea on integration testing and load testing. Will be having different tools for these testings as well. So even though you need not to dive deep into this, at least we should be having a basic idea like what is a load testing, like how will you do a load testing, how would you derive a breakpoint, or how would you derive a threshold point. All these things you need to know as part of testing. And then coming to the deployment, we will have blue-green deployments, like where we will be keeping one region live, and we will be testing in other region, and once that is completed, we will be making the region which we tested as live. That will come under blue-green deployment, and we will also see on continuous deployments. And we also should be aware of maintenance of an application, like how will we be fixing our bugs, how will be tracking all the bugs which were raised by the testing team or QA team, how will use Jira, and how to improve performance using more asynchronous ways, and how we will enhance the features, and all will be seeing as part of maintenance. So this is something into the software development lifecycle which we should be aware of. So now we will dive into methodologies. So methodologies, so the two famous methodologies which are currently trending in our market is agile methodology and waterfall methodology. Where in agile methodology, the requirements will be dynamic, like waterfall methodology is completely opposite to that, where we in the beginning days of industry we used waterfall methodology, meaning when we get a requirement, we will take a certain period of time and we will complete the requirement, and we will deliver it to the client, and once it is done, we will will be getting enhancement or changes as part. Again, we will be working on the same. Whereas agile is bit different. As part of agile, if there is any change, we will be doing it dynamically, and we will be going sprint wise in agile. We will be having scrum calls, we will be having kanbans, and all that will be seeing as part of agile methodology. So now we will see about the coding practices. These are nothing but the websites which help you to practice coding, and where you can boost your confidence by completing the exercises which are present in these websites. Like you can go through Lead Code, Hacker Rank, Code Wars, Codility, based on your experience or based on your difficulty level, whether you are a beginner or intermediate, or you are an advanced pro. Based on that, you can choose your own website and solve the problems in that website, so that will be very helpful in your interviews. So there you have it, the comprehensive roadmap to becoming a software engineer in 2024. Remember, it's not just about learning these topics, but also applying them through projects and continuous learning. I hope this video serves as a helpful guide on your journey becoming a successful software engineer. Thank you for watching, and don't forget to like, share and subscribe for more content. Thank you.